Okay, hi guys, so we'll be continuing on seeing more on Gibbs free energy. So let's get started. So we have some examples that, let's say H2O2 aqueous gets converted into H2OL plus half O2G. Okay, so this is given that this is a exothermic reaction and delta Ng is positive in this case and delta Rs is also positive. Okay, next let us see this reaction. 3 moles of O2G converts into 2 moles of ozone. So in this reaction delta Ng is negative and delta Rs would be less than 0. Okay, let's see third step or third reaction. We have N2O4G getting converted on heating into 2 moles of NO2G. So delta Rs for this reaction is positive. Okay, fourth reaction is we have N2G reacting with 3 moles of H2G and forming 2 moles of NH3G. So delta Rs for this reaction is negative. Okay, and this is a exothermic step or a reaction. And also we can write that this is a spontaneous reaction at low temperature. Okay, so now if T is less than T equilibrium, then T is called low temperature. Okay, and if T is higher than T equilibrium, then T is called high temperature. So this is a relative definition of temperature, whether it is a high temperature or a low temperature. So keep this in mind. Okay, next concept is delta G and useful work. Okay, or non-PV work. So we can write non-PV work as W non-PV or W useful. That would be equals to, rather in non-PV work and or useful work, no expansion or compression is involved. Expansion or compression is involved. Okay, and we can write that delta G is a measure of non-PV work or useful work. Okay, next we can write that electric work is a type of non-PV work. Non-PV work. Okay, so we already know that du equals to dq plus dw total, and we can also write that du is equals to dq plus dwpv plus dw non-pv. Okay, so in place of dw total, we are just substituting the useful work and the pv work. So for a reversible process at a constant temperature and pressure, we can write that for a reversible process at constant temperature pressure, we can write that du would be equals to TdS minus PdV. So we are just substituting the value of dq here, which is TdS. dwpv would be minus PdV plus dw non PV work. Okay. So just rearranging the equation, we would have du plus PdV as rather minus TdS also would be equals to dw non PV. Okay, so now we can see that du plus PdV can be written as dH minus TdS would be equals to dw non PV. Okay, and dH minus TdS can be written as dg of system at constant temperature and pressure can be written as dw non PV. Okay, so this can also be written as delta G system at a particular temperature and pressure would be equals to W of non PV work. So we can write that useful work done on the system would be equals to the increase in Gibbs energy of the system. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on non-PV or useful work. So till then, good luck and goodbye.